Hi friends, my name is Narsimha and I'm pursuing my BTech in Institute of Aeronautical Engineering College. Today, as a part of my AIT Tech Talk videos, in the subject of compiler design, I want to explain a topic named Deep Learning Takes on Translation. It is a research topic. First of all, going into the lecture, first of all, what is meant by deep learning and what is meant by translation, how this deep learning is being used in this translation, we want to know. First of all, translation, a familiar word which we'll come across in our day-to-day life. For example, in our country, there are many languages which are being spoken by the people. So, if we want to convey our expressions or convey our message to other person who is not fond of our language, so we will use a Google Translator, which is also known very familiarly to all the persons. So, in this Google Translator, we will say the words or the message in the English, for example, and we will take the language of the other receiver person and we will convey our message. So, in this translation part, how these deep learning techniques are being used in our day-to-day life and how this model has been improvised and how the accuracy of the translation is being increased. We'll see in our lecture. So let's get into the topic. First for introduction. Over the last few years, data-intensive machine learning techniques have made dramatic strides in speech recognition and image analysis. Now, these methods are making significant advances on another long-standing challenge, such as translation of written text between languages. Until a couple of years ago, the steady progress in machine translation had always been dominated by Google, with its well-supported phrase-based statistical analysis, said Chongjin Chu, an assistant professor of computer science and data science at New York. So, first of all, as we all know, this machine learning techniques means the artificial intelligence or deep learning or machine learning, all these techniques have been used in our day-to-day life. Like, for example, Alexa, which is used for speaker recognition, which is all fond of it. So, in these all techniques, the machine learning techniques have been used so to increase the accuracy and it is well defined in speech recognition and image analysis. So in the same way, it is also being used in the translation means part. However, we'll see it. This is an image to show the old translation and the new translation. Here you can see the German to English and here also German to English. So the sender is picking a language of Germany and now it is going to be converted the whole message into the English. So you can see here. So the difference between the old translation and new translation by using deep learning techniques is shown here in the form of image. Once have a look. You can see that no problem can be solved from the same consequences that they have arisen. But in new translation, problems can never be solved with the same way of thinking that caused them. So in the older translation, the synonyms means the person who is a receiver said should understand the meaning of the word. But in new translation, it is easy to understand for any person who knows a little bit of English. For now, data posted by Google in November 2016 show that its new system is now essentially as good as human translators, at least for translation between European languages. So, when a person translates his message in another language to a receiver, it will be easy to understand. But when a machine translates the same message, it is somewhat difficult for the receiver to understand because due to the usage of synonyms or antonyms or any different type of grammar used by the machine. But a person can understand the emotions of another person or the knowledge of another person and can easily translate his message in the language of the receiver in the understandable way. So nowadays the Google in 2016 the Google has been shown that the human translator is equals to the Google translator, means the both are in the same format that it will understand the emotions of the receiver person and converts the message in the convenient way. Now, the neural networks, the mainly uses the technique, deep learning technique. The architectures that enable these advances as well as the methods of configuring them are fundamentally similar to those developed in the late 1980s, says Jan LeCun, director of AI research at Facebook and a professor at NYU. These systems employ multiple layers of simple elements that are extensively interconnected like those in the brain, inspiring the name neural networks. Individual elements typically combine the outputs of many other elements with variable weights and then use a nonlinear threshold methods to get their own output. So now, we all are familiar with networks. Means our brain is consisted of many neurons means if you want to think anything or recall any memory, all the neurons in the brain of that part should be in an active position, to deliver the message to ourselves. So the neurons are interconnected, any thousands and thousands of neurons are interconnected in between them to translate or to pass a message to our body. So in the same way, the same word is being used in the form of neural networks as a deep learning technique in this domain. In analyzing a message, for example, initial layers might compare nearby pixels to identify lines or other primitive features, while deeper layers flag progressively more complex combinations of features until the final object is classified as, say, a cat or a tank. The specific analysis a particular network performs depends on the numerical weights assigned to each interconnection and on the details of how their combined output is computed. The challenge is to set the parameters for a particular task by exposing the system to a large series of inputs whose desired outputs are known and sequentially adjusting the parameters to reduce and discrepancies. After such training, with known examples, the network can quickly extract high-level information from a novel low-level representation. With a large enough set of examples, this training can be done without even specifying which features are needed for classification. So here in neural networks, first of all, a model is been, for example, I will say in easy way, a model is been created. For example, there's a bunch of animals, means a data set of animals is there, and you want to identify which animal is present in the data set. So for that sake, you have prepared a model. In that model, first of all, you have to train that model, means you have to say that by training, this is a cat photo, this is a cat image, this is a dog image, this is a tank image, this is a road image, something images with a huge data set. You have to train the model. The model should be trained in the way that if anything, means any test data is given to that model, it should identify which image is there in the data set. So after training, you have to give test data. So after such training, you have to get test data, and by the test, viewing the test data, by the output given by the model, we can find the accuracy, means how much accuracy it is in. For example, the data set I have given a cat image. If the model has recognized it as a cat image and given the answer as cat, my accuracy is 100%. Otherwise, if a model has given it is a tank image, means for example, it is given output that it is a tank image, my accuracy is not 100%, it is somewhat 30% or 40%, depends on the number of outputs given by the model. So in the same way, we have to again train the data. First of all, deep learning. What is deep learning? Neural networks are often described as deep learning. Neural networks, which I said before, are also known as deep learning. The phrase encompasses systems that perform more complex functions than traditional neurons, but it also sidesteps the somewhat checkered reputation of neural networks. Most translational implementations employ an encoder network and a decoder network that are trained as a pair for a choice of source and target language. Even when automated systems are excellent on average, they occasionally can make mistakes that humans find shocking. An IBM fellow at IBM's Thomas J. Watson Research Center in New York said by him. 15 years ago, he and his colleagues developed a computer-based translation metric called Bilingual Evaluation Under Study, or BLEU in shortcut, which is still widely used and helpful for quality control and tool improvement. This is an assessment quality. First of all, as I said before, a machine, however it is trained with huge data set or however it is trained with emotions of a person, anything, it is not as apt as a human brains can think. So said by J. Watson, Research Center Fellow. So they have developed, he and his colleagues have developed BLEU, which are using widely. Then into translation. Most implementations of translation employ two neural networks. The first, called the encoder, process input text from one language to create an evolving fixed length vector representation of the evolving input. The second is decoder. Network monitors this vector to reproduce text in a different language. Typically, the encoder and the decoder are trained as a pair for each choice of target source and target language. An additional critical element is the use of attention, which Chu said was motivated from human translation. Which I said before, in this translation, the deep learning technique is used, and there are two parts. Implementations should be done in the translation in neural network. That is, first one is encoder and second one is decoder. In simple way, we are giving a text in our language, for example, German. So the purpose, means work of encoder is to maintain a fixed length of the message and saving the vector representation of Germany language. And second thing is to convert the Germany language message into the English language message. So that work is performed with the decoder. That's it. A universal language. The separation of the encoder from one language from the decoder for another language raises an intriguing question about the vector that passes information between the two. As Google put it on in a November 2016 blog post, is a system learning a common representation in which sentences with the same meaning are represented in similar ways, regardless of language. That is an interlingua. This is a question raised by Google. This possibility is reminiscent of the universal language envisaged by 17th century polymath Gottfried Leibniz for formally denoting philosophical, mathematical, and scientific. Revaluation in progress. How this revaluation of the work has been revaluated. When dealing with languages from different linguistic families, reprocessing of the text can significantly improve translation. Based on this experience with neural networks going back to Bell Labs in 1980s, Lee Kuan cited a fourth reason for the upswing in deep learning. Besides fast computers, big data, and new ideas, people started believing. The reputation of neural nets as Swingy, he said, began to break down with widespread sharing of code and methods and a steady stream of solid results. First in speech recognition, then in image processing, and now in natural language, understanding and translation in particular. It really is an evaluation set by Lee Kuan. It's an incredible short time for going from blue sky research to industry standard. All the large companies that have big language translates services are basically using neural nets. The main domain which is using language is natural language processing, which you all are familiar, I think so. Speech recognition. For example, you are saying to Alexa, play music from pop music or any hit movie. So, any popular movie want to play music. You will say, Alexa, play the music. So, how is Alexa is being trained in the way that if you are saying Alexa play the music or Alexa play music or Alexa music, in any way you are saying it is playing the same music. How? So it is trained in a way that if any name manner said by the human, the keywords, if is specified, then react to the keywords. It is trained in that way. So if we not say in a proper sentence format also, Alexa is going to respond. So thank you, friends. And first of all, I want to recall all the contents of my lecture notes. So here's the introduction. This is the main image of our topic. It is deep learning takes on translation. This is an neural networks, which also known as deep learning. This is a content about the neural networks, the process, and the turning to translation, that is encoder and decoder work performed in the translation, universal language, revolution in progress. And thank you, friends. I hope my lecture is useful for you. And thanks for watching. Thank you.